Hello and welcome to Bathrobe Science. So as you can see, I've got my bathrobe on, and today I thought we would discuss a simple trick to help you with algebra, preferably linear algebra type equations. So here's a good resource. We're going to be talking about equations of two or more variables, and I'm going to be showing you one, how to solve them, and two, how to solve them quicker. Like, let's say you're in a test or something like that. So how we're going to do that is row echelon form, and this will allow us to double check answers really fast, and it'll also allow us to just to solve things quicker on tests and whatnot, right? So this doesn't work for, say, like your regular quadratic equation or whatnot, but it does work splendidly for other types, for linear equations. So nothing to a power. So we're going to start with this problem right here. So I'm going to copy it onto the board and show you guys how to solve it, both the common way and in the row echelon form. So we've got 3x plus 2y equals 1. And yeah, I'm going to show you with just two equations of two variables first, and then we'll talk about three equations of three variables. So plus 1/2 y, and this equals 0. Okay, so the first thing is we want to get everything in terms of x or y and figure out what these things equal, right? So if we subtract the bottom equation from the top one, we can get there. But first of all, I'm going to convert this into row echelon form. So in row echelon form, you have these brackets on the side here, and then you have a bar, and so you got your 1 and you got your 0 over here. You've got a 3, you've got a -1, because that's a -1. You've got a 2, and we've got a 1/2, right? So if we want to make this a 1 and we want to make this a 0, the simplest way to do that is we're going to subtract this row from this row. But we're going to multiply this row by 2 when we subtract it. So 3 minus 2 is going to give us a 1. And then we've got -1 down here. So if we're multiplying this by 2, it becomes a 1. And so if we have to add these two rows because this is a -1. So if we add these two rows, this becomes a 3. And anything times 0 is still 0, so this stays the same. So we've got 1/2, right? Yes. So that's going to go back to here, and this is going to be x plus 3y equals 1. And the bottom's the same, so that's still minus x plus 1/2 y equals 0. Alright, so we scroll down a bit here. The next step is we want this guy to be a 0 because we want everything in the bottom to be in terms of y. So all we have to do is add this line to that line. So what we get in row echelon form, which is, well, we're progressing towards row echelon form. I'll show you what row echelon form is at the end. So we still have 1, and we still have 3, and we still have 1 over here, we still have 0 down here. Now 1 plus -1 is 0. 1/2 plus 3 is 3.5, which is 7/2. And we don't have a 0 down here anymore. Instead, we've got 1 plus 0 is 1, so we've got a 1 down there. So we've got 1, 3, 1, 0, 7 halves, and 1. Okay, so this is going to still be x plus 3y equals 1. But on the bottom now we have 0 times x, which means that you can basically ignore that, plus, because 0 times anything is 0, and we have 7 halves y equals 1. So now we know what y is, right? So let's multiply the bottom by 2 over 7, this whole bottom row. So that's going to mean we have 1, 3, 1, and then we're going to have 2 sevenths. We're going to have 1, and we're going to have 0. So that goes to x plus 3y equals 1. And then we have y equals 2 sevenths. Okay, so we're still not done yet because we don't know what x equals. So to get x, we're going to subtract twice this row on the bottom from this top row. So we've got 1 minus 0 is 1. So anything 2 times 0 is still 0. We've got 3 minus 2. Or no, wait. We want to eliminate 3 completely. So we're going to do it by 3. So 3 minus 3 is going to be 0. And then 3 times 2 sevenths is going to give us 6 sevenths. So we're going to have 7 sevenths as 1 is, because 1 is equal to 7 sevenths. We're going to have that minus 3 times 2, which is 6, over 7. So we're going to have 1 seventh. And we got 2 sevenths. And then we have a 0, and we have a 1. So that means that we have x plus 0y equals 1 seventh. So since we can, 0 times y is 0, x equals 1 seventh. Now on the bottom we have 0x, which we already said doesn't equal anything because 0 times anything is 0, plus y equals 2 sevenths. Now, if we scroll up to the top, you can see that minus 1x plus 1/2 y equals 0. So 1 seventh negative plus half of 2 sevenths equals 0. And you can see that's absolutely correct if we plug them back in, because 1 seventh plus 1/2 times 2 sevenths, this is negative over here, cross those two out, this is just 1 seventh now, equals negative 1 over 7 plus positive 1 over 7 equals 0. So that's how you reduce to row echelon form over here, and it's much, much faster than doing your regular old equation stuff. So 3 equations of 3 variables is the same. Now the thing you have to be wary of in 3 equations of 3 variables is, first of all, let me delete all this. Okay, so in 3 equations of 3 variables, you might not get an answer. So, like let's say I had 3x plus 2y minus z equals 1. Then we had, let's say I have the same thing again, so 3x plus 2y minus z equals 1. And then I have a different equation. So I have negative x plus 1/2 y minus z equals 1. Now if I were to write this out, it would be 3, 2, minus 1, bar 1, 1, 1, minus 1, minus 1. Here we're going to have 2 again. We're going to have 1/2. Here we're going to have minus 1. Here we're going to have 3 again. So we can see that these two equations are the same. So that's not going to work out for us, because if we subtract this equation from that equation or that equation from this equation, we end up with all zeros in this row. And no matter how you work these equations out, one of these two lines will end up being all zeros. So we can see that we're going to get 3, 2, minus 1, 1. This is going to be a 0 now. 0, 0, 0, minus 1, 1/2, minus 1, and then you're going to have a 1 here. So that means that we only have this equation and this equation to work with. So if we subtract this line from that line, we can turn this into a 1, so we'll do that twice. So 3 minus 2 is 1, and here we have 1/2. So 2 plus 1 is 3, and then we have a minus again. So -1 plus -2 is -3, and we got a 1 there. I'm just going to put the zeros on the bottom, because it doesn't matter what order you have the equations in. Now we've got minus 1, 1/2, minus 1, and 1. So it's going to be, this equation here in the middle hasn't changed since the beginning, but this equation up here is now x plus 3y minus 3z. Oh, and we had, this would be a 3, 2 now, because we added this equation to that one twice, equals 3. So that's what this top line equals now. Now, if we add this top line to this middle line, a lot of things are going to drop out for us. So that's going to be 1, 3, minus 3. And we got a 3 here. Put zeros on the bottom. Okay, so 1 plus 1, or yeah, 1 plus minus 1 is 0. Now we're going to have our same 7/2 here from the last example. So we're adding these two together. And now adding these two together gives us minus 4. Adding these two together gives us 4. Now, we have an equation of 2 variables, and that's as good as we're ever going to get. And I'll show you why. If we pull back up row echelon form, you can see that reduced row echelon form, and this doesn't show it too well, but basically what you want is you want a 1 on all your diagonals. And that basically tells you that you have 1x equal to something over here, and you want everything else to be zeros. So you want a 1 here, you want a 1 here, and you want a 1 here. Well, wait a minute. We can't possibly get a 1 here because those two equations were the same. So we're never going to be able to solve for an exact value, which in real-world equations is better, because basically the best equation we're going to get out of this is 7/2 y minus 4z equals 4. And that's what this one in the middle here is telling us. So that's going to give us a line. And that's great because that tells us we can pick one of these two and then we can plug it in, we can get an x, but I'll show that more here. So if we multiply this by 2/7, we're going to get 1, 3, minus 3, and then 3 again. Now, multiplying that middle row by 2/7 all the way across is going to give us 0, because 0 times anything is 0. We're going to get a 1 here. We're going to get negative 8/7 here. Then we're going to get we're going to get 8/7 here. Now, I want to eliminate this guy right here. Now this guy here equals y minus 8/7 z equals 8/7 in the middle. So I'm going to subtract this one doubly from this one up here. So we go 1 minus 2 zeros is 0, so all this stuff, that's still a 1, and these guys are still zeros. 3 minus 2 minus, we're going to minus by 3 ones. So 3 minus 3 is going to be 0. Now 7 minus negative 7 minus 24/7 is going to give us 7 times 7 is 49. 49 plus 24 is 73. So we're going to get, but we are subtracting these two negatives. So this guy down here is going to be 24. That one up there is going to be 49. We're going to end up with negative 25/7. Down here we're still going to have negative 8/7. Then we're going to have, okay, so we're subtracting these two. So up top here, we have 18/7. No. 21/7. And since we're subtracting it from 24/7, we're going to end up with negative 3/7. And then we have 8/7. And that's as good as our equation gets. So what we have here is we have x minus 25/7, and that is z's equals negative 3/7. And then on the bottom here, we have y minus 8/7 equals 8/7. And no matter what you do, you can't get this term in the end to drop out, because if I add this line back to this line, I'm going to get another term to show up here in the y place on the first line. If I add that term to this one, I'm going to get another term in the x one. So this is as close as I can get as the equation of two lines. And these lines defined a flat surface. So think of, here, if I pull that up again, we can see basically we've got three planes we're working in, right? And we've got these three sheets over here. Well, because we have two lines, they define a flat plane in this three-dimensional surface. So that's going to be one of these like yellow or pink or green planes that we've defined. So any answer on that plane is acceptable, but there's an infinite number of them. So as long, let's do z here too. As long as you pick, for any z you pick, you can get an x or a y, basically. And you can flip this on its head. So you can plug this equation into that equation. So you have an equation in terms of x and y, and in terms of y and z and x and z. So then you would have three equations, but they're still interdependent. But then you could pick, like, let's say x or y, and it would give you a z and y, or a x and z for said picks. So basically you can pick any number you want to, and there's an infinite amount of them in this plane. And that's how solving equations with reduced to row echelon form works. So it gives you all sorts of options. It's crazy fast because it organizes your data so you can see exactly what you need to do. Okay, well, this has been Bathrobe Science, and sayonara.